Hi everybody, we're going to be talking about conditional probability this week. I also attached a video about the 2020 census that Ms. De La Vega wrote up. It is super important to take the census, to fill out the census. I've already done so for my household. It's one person per household that needs to fill it out. So please take a couple minutes to watch that video. Talk to your parents, ask them if anybody has filled out the census. If not, take a couple minutes to do that. It relates to this week's lesson just because of the idea that it is a survey that is sent out to everybody in the entire nation. It also really helps in terms of funding. So funding for scholarships, funding for just public education, funding for roads and, maintenance, bridges, etc. So again, more details on Ms. De La Vega's video. Take a couple minutes to watch that. But my video is specifically about conditional probability, which is the area of focus for us this week. So you already did an assignment on just general probability, two-way frequency tables last week. So I'm going to kind of extend on that idea, but in a different context. And so what is conditional probability? Conditional probability, what we're learning about this week, is the probability of an event, A, given that another event, B, has already occurred. So that's the conditional part of it. The condition is that one event has already taken place, and you're trying to see within that event, what is the probability that another event is taking place. So let's go on to an example. So in last week's assignment, you guys saw this question. And so this question said, in a survey, 607 general surgeons and orthopedic surgeons, so 607 surgeons in general, that's our grand total, indicated their major professional activities. So some surgeons get money from teaching, some surgeons get money from research, and those were their two general activities. The results are summarized in this two-way table. And so the reason it's called a two-way table, again, is just because we're talking about two topics, general and orthopedic surgeons. But in context of both of those, we're looking at two activities, teaching and research. So two different ways to read this, left and right and up and down. So in last week's assignment, this was the question that you all got. So the probability with a two-way frequency table. If one of the surgeons is selected at random, which of the following is the closest to the probability, or is closest to the probability that the selected surgeon is an orthopedic surgeon who indicated their professional activity is research? So here are some keywords to be looking for in this problem, and I'll show you how this problem is different from conditional probability, which is what we're doing this week. So for this one, it says if one of the surgeons is selected at random. So it means any of these surgeons, whether it's general or orthopedic, if one of those surgeons was selected at random, that really means that we're selecting a surgeon out of the total 607 surgeons. So it says out of any of those 607 that we picked at random, which one is closest to the probability that we happen to pick an orthopedic surgeon whose indicated professional activity is research. So here's where we narrow it down. So since this probability is a random one out of the total population, I'm really looking at these two criteria and where they overlap. So an orthopedic surgeon whose research or whose major activity is research. So orthopedic, research, this is where both of those two columns overlap with each other. So this answer, or to get this answer, should have been 74, because there were 74 people that indicated they were orthopedic surgeons and they did research. And of those 74, we're saying that the probability of me picking this person would be out of the total 607 surgeons. So when I think about this, 74 divided by 607 gives me an approximate decimal of 0.1219, let's say. I don't know why I wrote it so weird there, sorry. 0.1219. So that means looking at these, the closest probability I would say is A, because I could round this 1 up since the next number is 9. So 122 is what I would say. So notice with this example, it's a random sample out of all of the surgeons. Now here's where conditional probability is a little bit different. If this was a conditional probability question, like the questions that you're getting this week, this is what the question would look like. It would say something like, of the orthopedic surgeons, so this is our condition A, so this is the first condition that happens if we have an orthopedic surgeon, what fraction indicated research as their professional activity? So again, we're looking at research. Notice these two look very, very similar. The main difference is that in this problem, we indicated an event that must take place first of the orthopedic surgeons. So I'm going to go through and just erase what I have written here and say that for this conditional probability, I'm looking at just these numbers, this event right here. And so once I look at and I narrow down my information to this one event, then I can go on to the next part that says what fraction indicated research as their professional activity. So now if I come back up and I look at these orthopedic surgeons and I look at research, I can still see that I'm using 74, but I'm not doing 74 out of the total number of surgeons. I'm doing 74 out of just this one event, orthopedic, so out of 193. So in this case, my answer would be D. So I gave you some examples like this for this week, and they, again, are practice SAT questions because I felt like that was probably the most useful and most applicable type of question for you guys at this point, since a lot of you either are going to take the SAT or ACT to get into college. So yeah, hopefully that'll help you prepare a little bit. And you can always Google practice SAT, and there are a bunch of practice tests that are released that have some English components as well. So I recommend that you guys look at that during the summer just to kind of prepare yourselves for college entrance exams. Okay, let's look at another example. So if we look at this table of data for students with asthma versus students who have at least one household member who smokes, we can see that this is another two-way table. So two ways meaning we can look at the information of household smokers or non-smokers, or we can look at students who have asthma or don't have asthma. So there's a couple different ways to read this. We're going to look at this and determine which one of these questions or scenarios, events that I give you are considered conditional probability or not, and then we'll calculate probability for all of them. So for our first event, let's consider a randomly selected student has a household member who smokes. I like to think of these as if-then statements. If you think back on geometry, these logical conditional statements kind of help me make sense of this information. So if I'm given a random student, so randomly selected, then that means, or that would imply to me in this event, that they've got somebody in the household who smokes. So if I have a randomly selected student, then I want to determine the probability of them having a household member who smokes. So again, based on the example we did last time, a random student would imply that it's any of these total students here. Since it's a random student altogether, they didn't give us an initial condition. This would mean that this is not conditional probability because it's just a random student. It's not necessarily one with asthma or one without asthma. So this is not conditional probability. So to calculate this probability, I'm going to calculate it out of the entire population of 937 students. And so to figure out what I'm dividing by 937, I want to look at students that have a household member who smokes. So having at least one household member who smokes, it could be somebody with asthma or somebody without because they didn't specify. I'm going to look at the total. So 395 out of the 937. So if I think about that probability, we can say that this is going to be about 0.42. So that would be the probability, or you can think of it as 42%. So the probability of this event happening would be about 42%. But this was not conditional probability, so let's take a look at the next one. The next one says a randomly selected student who has asthma, so that would be my first condition, who has asthma. So going back up here, a randomly selected student in this asthma category. So this is my condition. The second part of it is going to be a household member who smokes. So if a student with asthma is selected, then we can say that they've got a household member who smokes. So this one I would say yes is conditional probability because it gives us this initial condition, has asthma. So out of the total number of students with asthma, that's 182. So I'm going to be dividing by that total 182. But the number I'm dividing is the household members that smoke. So going back up here, out of this condition, the ones that have household members who smoke are 113. So I'll be doing 113 out of 182. And so that gives me approximately 62%. So there's an example of conditional probability. Now let's look at the next event. It says a randomly selected student who does not have asthma. So now we have an initial condition here, students without asthma. And we're trying to figure out of those students without asthma, we're looking at the ones that have a household member who smokes. So again, yes, this would be conditional probability. Let's go up here to look at the information we need. So we don't need this anymore. Now we're looking at students who do not have asthma without asthma. So now I'm looking at this other column, or row rather. So out of these total students, out of 755, I want to look at the ones that do have household members who smoke. So 282 out of 755. 282, okay. So again, putting that into my calculator, 282 students out of the total 755 that do not have asthma, that'd give me about 37%. So that would be the probability of this event occurring. If I look at the next event, a randomly selected student who has a household member who smokes has asthma. So again, my if, or my initial condition, is a random student with a household member who smokes. So this is the initial condition I'm looking at. And out of those household members who smoke, I want to look at one that has asthma. So I'm going to come back up here. I'm going to erase all of this stuff. Now my initial condition is of the people who smoke. So out of this column, out of all of these 395 people who have household members who smoke, we are specifically looking at the ones that have asthma. So has asthma. 113 out of 395. 113 out of 395. Again, we're going to say yes for this conditional because our initial condition was the household member who smokes. So 113 out of 395 will give me about 29%. 0.29. So again, notice how these are very similar, except the initial condition up here in number 2 was the student with asthma was selected, and then we looked at the household members who smoke. This one was switched around. This one, the initial condition was the household member who smoked, and then the secondary part was they have asthma. So notice these two are two different percentages because of the initial condition kind of switching around. So that's important to note. And then our final example, a randomly selected student who does not have a household member who smokes. So now we're looking without a household member who smokes. And then we're looking within that condition if they have asthma. So without smoking, let's erase this part that we had. Out of the people who have no smokers in their house, we are looking at people who have asthma. So out of this total, we want the ones that have asthma. 69 out of 542. And again, I would say this is conditional probability because it has this initial condition, a household, that should have an L, household member without a household member who smokes. So looking at my calculator, 69 divided by 542 would give me about 13%. So there's about a 13% probability that a random student who doesn't have a smoker in their house has asthma. Next week, we're going to be talking about how to interpret some of this data. So it's important that you look back at the information. Notice this small percentage shows us that it's really less likely for a random student with a household who has no smokers to have asthma. So we can see a correlation here that it's not really likely for them to have asthma given that they have a household without smokers. But if I go up to maybe the highest probability here, if I picked a random student with asthma and they have a household member who smokes, we can see that that's a much higher probability. So it's much more likely for them to have a household member who smokes and also have asthma. So again, we're going to look at how to interpret this information a little bit later on, probably next week. But for now, I'll give you a couple problems or a few problems, practice SAT problems with this conditional probability in mind. So think about, what is your first condition? What are you narrowing your information down to? And then out of that total population, which portion are you looking at specifically? So I hope that helps. Please let me know if there's anything confusing, or show up to office hours. They are Tuesdays and Thursdays at 3 o'clock. I'm on Google Meet to help you guys out if you ever need anything. So just pop in if you need any help. Otherwise, I'll see you next week.